In this video, we'll have a look at making our camera follow the movement of our player. Not really much to say about that, let's just jump into it. So as with everything else in game development, making the camera follow the player can be done in multiple ways. The first and most obvious one is probably just parenting the camera to the player. Unity allows us to nest game objects. That means that we can take our camera here selected and drag it under our player. We have now parented our main camera to our player, and the main camera is now a child of that player. This means that whenever we go and move our player, the camera is going to move with him. However, the problem with this is that if we go ahead and rotate our player, the camera also rotates with them. And that's going to look very weird when we collide with something and the cube starts spinning, then the camera is going to spin with it and everything's going to be confusing. So what we do instead is we take our camera and unparent it, and we make it follow only the position of our player using a script. So let's go and hit add component. We'll call it something like follow player. Select C# and hit create and add. Let's double click it to open it up in Visual Studio, and let's clean up the script a bit. So let's delete the two using tags up here, and let's also delete the start method. Now, just like when we wanted to move our player, where we wanted to move him a tiny bit each frame, we also want to have our camera snap to the position of our player each frame. So we'll put our code inside of the update method. However, in order to set our camera's position to that of the player, we need a reference to the player. The easiest way to do this is by making a variable that stores the reference to our player. So when we create a variable, we write public, and so far we've only looked at the basic data types, stuff like float, integer, and string that stores numbers and text. But variables can actually also store way more complicated stuff. If we go ahead and write transform here, we can basically get a link to our player with information about his position, rotation, and scale. Remember, the component responsible for these things are indeed called a transform. So that's what we're getting a reference to. Then of course we need to name it something, but we'll just name it player. Let's close that with a semicolon, and if we just try and hit save now and head back into Unity, we see that an empty slot called player now appears. All we need to do now to make this player variable point to our specific player is to take the player and drag him into that slot. So now every time we write player in our code, it refers to that object. To test this, we can go inside of our update and we can try displaying the position of our player in the console. To do that, we write debug.log to write a message to the console. Inside of the parentheses, we then write player.position, and we close it off with a semicolon. Now every frame, we should display a message in the console with the position of our player. Let's save that, head back into Unity and hit play. And if we go and select our console, we can now see that position updating. If we select our player, the two numbers should correspond. So we can see here that our player is currently falling, and so his Y value is rapidly decreasing, and it does the same thing in the console. We can also see that he's moving a bit forward on the Z. Again, he's also moving forward in the console. So now that we have this link between our script and the player, we can take the position of our player and feed it to the camera. So let's stop playing, head back into Visual Studio, and instead of writing the position of our player, we'll go transform, and whenever we write this with a non-capital T, it refers to the transform of our current object. That means the object that this script is sitting on. It also says so here, the transform attached to this game object. So by writing transform and then dot position, we're referring to the position of our camera because our follow player script is sitting on that object. And just like we were able to display a position, we can also set it equal to something else. So now we could move our camera anywhere in the world, but we want to move it to a very specific place, and that's the position of our player. So we'll set it equal to player.position. And again, we'll close this off with a semicolon. So now our camera's position, this game object's position, is going to be set equal to the player's position every frame. So let's save that, head back into Unity, and technically our code doesn't have any errors, but there's a main problem with this. Let's try zooming out in the scene view so we can see what's going on, and hitting play. We can see that indeed our camera is following the player, but it's following the center of our player. And that means that right when we start the game, our main camera snaps to be inside the player object. You can see that the effect here is that we're getting kind of a first-person view. Of course, this might be something that you want for your game, but in our case, I think it would be better if we move our camera a bit back from the player and a tiny bit up. To do that, we'll create another variable. So again, we'll write public, and I'm going to introduce you to another data type. This one is called vector3. And a vector3 is actually really simple. All this does is store three numbers. A float stores one number with decimal places. A vector3 stores three floats. And that makes it really easy to use when it comes to positional data, because we have an X, a Y, and a Z. So if we go ahead and name this one offset, save it, and go into Unity, we should now be able to specify an offset on the X, Y, and Z value. So in our case, we want it to remain centered on the X. So we'll leave that at 0. But we do want it to lift it a bit on the Y here. so we'll set that to something like 1. And we definitely also want to pull it back. So we'll set the Z here to something like -5. So now that we have this offset on the different axes, all we need to do is add it onto our player's position. So to do that, we'll go in here and say player.position and then plus offset. And we are very used to seeing the plus here being used between two numbers, but unless you have experience with college level math, you probably haven't seen it between two vectors. How do we add 3 numbers onto other 3 numbers? It's kind of weird. If you want to learn more about what's going on here, I have a video on vectors that you should definitely check out. Basically what's happening is we're taking the x position of our player, which is currently 0, and we're adding 0 onto that, so that's still 0. Then we're taking the y, which is 1.16 in this case, and we're adding 1 onto that. And then finally on our z, this is currently 0 as well, and we're adding -5 onto that, so that's -5 on the z. And we keep doing that as the player moves forward. So in this case our x would still be 0, our y would be 1.16 plus 1, which is 2.16, and our z would be this number -5, which is equal to 1.63. So make sure you save your script and hit play, and our camera should now follow our player with a nice offset position. And this is much better than parenting, because if we tilt off the ground here, you can see the cube rotating, but the camera staying in place. So that was pretty much it for this video. If you liked it, make sure to subscribe so you don't miss a future episode. Also, a lot of you guys have been saying that you aren't notified when I upload a new video. So make sure that doesn't happen, click the little bell icon next to the subscribe button and hit send all notifications. Why YouTube? Why do you have to do that? We don't know. Other than that, I will see you in the next video. Thanks to all of the awesome people who donated in January, and a special thanks to Derek Heemskirk, Faisal Marify, James Callahan, Robert Bonham, Peter Locke, and Jason Tito. If you want to become a patron yourself, you can do so at patreon.com/brekkies. Thanks a lot, guys.